So then what do you do if there's a function on the top and the bottom? We've got to have a constant somewhere. We need constants. All right, so how we do that? What we can do is we can break this integral up over an interval. So this equals the derivative from, so what I'm going to do is I'm going to break between sine and cosine, and I could put any value at all in here. It could be 0, it could be a, you know, I could just leave it a, leave it unspecified. I'm going to call it 0, why not, just because I can. I basically can make up any value. Because of the way I'm just splitting up this integral, plus the integral from 0 to cosine x of t squared dt. So basically I'm saying split the integral somewhere. Doesn't matter where. I picked 0 because why not? But it doesn't matter, it's going to go away anyway. Now, all I have to do is, like, this one's ready to go. I just got to flip over this one. So that's going to be the derivative of negative 0 to sine x, because I need the constant on the bottom. T squared dt, plus the integral from 0 to cosine x of t squared dt, right? Because what's going on here is I need a constant on the bottom. Need constant on lower limit, not upper limit. So that's why I flip this one over and make it negative. All right, so I mean, you can sort of jump to the solution from here. I'm going to rewrite a little bit. I'm going to distribute the derivative, because the derivative of the sum is equal to sum of the derivatives. So sum of the derivatives are equal to the sum of the derivatives, is equal to the integral from 0 to sine x. I just brought the negative out front, t squared dt, plus the integral from 0 to cosine x, t squared dt. Now, so what we're going to do, now that we've got our constants where they belong, and we've got our t dt x around, right? So what we're going to do is plug the sine x in, plug the cosine x in, but since they're both functions, I'm going to have to go times g prime for both of them. So this one's going to be, don't lose my negative sine of x squared, and then times the derivative of sine of x, which is cosine x, right? So I have to go times my inner function from here, my g prime. Because remember, the inner function doesn't really come from here. You might have something else going on here. That inner derivative comes from here, the upper limit of the integral. All right, and then so we're going to have plus cosine of x squared times the derivative of cosine, which is negative sine x, and that's that. And then, you know, it'd be nice for me to, so I put the cosine x in there, I put the g prime there. It'd be nice for me to simplify this out a little bit. Usually we don't write sine of x squared, we write sine squared x, cosine x plus cosine squared x sine x. Oh, I should have put that negative out front. Let's put that negative out there. And then since I made a mess, I'll just rewrite it. Negative sine squared x, because I've got all day, because these are so easy. Cosine squared x sine x. There you go. That looks a little nicer. All right. So feel free to really just, so what do you need to show in terms of justification? For this problem, you really need to show this step right here. We need to show that step. All right. Probably we could jump from here all the way down. I think it's pretty clear how this arises from that. But I would show at least this intermediate step, how you broke up the interval. All right, so that's that one. That's sort of the harder ones of those. Okay, so the next thing we have is indefinite integrals. And we're going to go to our old friend, John Rogowski. Here's John. I think he actually, yeah, and also I always forget about Ray Cannon. Yeah, I can't forget about Ray. We've got John and Ray going here, calculus guys. All right, and so it says we're doing these in evaluate the indefinite integral. So this is page 281. It will be posted on the Google Classroom, and they have you do things like number 8. Number 8, that's not the right one. Number 12. Okay, things like number 12. So this is Rogowski 281. Number 12. Number 12 says the integral x to the negative third dx. How do I know it's an indefinite integral? Look, no limits. It got no limits on it. All right, that means I can't get a value for it. I'm going to get a function. So I just raise the exponent 1, get negative 2. Don't be fooled by the negative, divide by the new exponent. But when you do an indefinite integral, you always have to put the plus c, because that plus c is like if I did the derivative of anything here, it would go away. And so this is an antiderivative of that. All right, so you're going to be maybe nice. I don't know, pull the 2 out. I don't know. You're going to write negative 1 over 2x squared. That would be nice. All right, there's really no work to show on any of these. So it's just a matter of, stating the solution and knowing where it came from. So that's how you do those. And now you get to make your favorite calculus joke. Don't forget to put the plus C there. You got to put the plus C. If you don't put the plus C, you're going to get a C plus. See, that's a classic standard calculus joke. Standard in all calculus classrooms. You will hear that in your calculus classes in university. If you don't put the plus C, you're going to get a C plus. Professors are required to say that. It's in the curriculum. So, do we got time to do another one on this video? We've got 5 minutes, 30 seconds. I think we can do that. Let's do number 24. So I wanted to point out that some of them are like a little weird. So number 24 has 12 minus z over square root z dz. How am I going to do that? That's like a quotient or something. You don't know how to do a quotient. We're going to learn it. But you do not know how to do the antiderivative of a quotient yet. You need to be able to break this up somehow. So this is you just break it up. You're going to do this with number 25 when you do the homework. Minus z over square root z dz. And then you go, oh, what this is 12z to the negative 1/2. And this simplifies. Z divided by square root z is square root z. So it's going to be z to the positive 1/2 dz. All right, so basically you just simplify it algebraically. I'm keeping on the integral sign in the dz because I haven't done any calculus yet. None of this is calculus, it's all algebra. Now I do my antiderivative, raise the exponent 1, we get 1/2. Divide by the new exponent. Raise the exponent 1, we get z to the 3/2 power, divide by the new exponent. Put the plus c because it's an indefinite integral. All indefinite integrals get plus c. Maybe we'll rewrite this nicely. This is the same as 2 times 12, so that would be 24 z to the 1/2. This is going to be so minus 2/3 z to the 3/2 plus c. You should probably leave it like that. If you really want, you can call it 24 square root z minus 2/3 square root z cubed if you want, but these are both fine. There you go, that's number 24. I'll do a couple more of the weird ones and then we'll be done with this.